This lesson is called Graphing Rational Functions, and this maybe be page 134? Is that right? Now, remember, what a rational function is, it just means there's a variable in the denominator. That's all it means. There's a variable in the denominator. Now, we're going to look right here. What we're going to talk about, excuse me, is a pretty simple rational expression. And I want you to take a look at that fraction, 1 over x. We're going to graph that thing. But I want you to look at that, and I want you to see if you can figure out, are there any numbers I could put in there for x that would make that fraction be undefined? 0. 0. Because 1 divided by 0 is 0. Now, that's the only number where that would happen. So that's the only number that's not going to be in my domain. Remember that word? Domain. Oh, yeah. Oh, how could you forget it? So, what I want you to do, and for those of you who are watching the video, I'm sorry. I'm going to have to go to my calculator on the smart board. You'll hear me talking. You just won't see anything. Please go to your calculator. And I want you to use your fraction command, alpha y equals, and I want you to type in 1 over x. Now, before you hit graph, I want you to go to zoom. Everybody see zoom? And I just want you to do a zoom 4. That's interesting. Now, I want you to go to table set, which is right here in blue. See that? So go to blue. Now, what I want you to do, I want you to put, let me see here. I want you to put 0 there. Actually, I don't. I want you to put 1 there. And I want you to go down where it says delta table. And I want you to put 0.01. Have you got that? Now I want you to go to table, which is second graph. Now what we're going to do is we're going to go back towards 0, and we're going to be looking in this y1 column, and we're going to be seeing what happens to the y values as x gets closer and closer and closer to 0. They do indeed. So just start arrowing up. So watch as those x values are getting closer and closer to 0. Watch what the y values are doing. What's ooh? What am I hearing ooh? Why do I get an error? Because why? Because when x is 0, that fraction is undefined. Right, undefined. Now, but look, what's happening as x is getting closer and closer to 0? What's happening to those y values? They're increasing. Now take a look. Look back at the graph. Look what we were doing. We were coming at x equals 0, which is right here, from the right, from 1, remember? And look at the y values. They're going up, 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 up. Do they ever touch 0? Do they ever touch 0? Why not? Because the graph's the function's undefined there. What do you think would happen if we came at x equals 0 from negative numbers? Why do you think they would decrease? Because they're going down. Now, here's where I want you to go. Go back to table set, right here. And I want you to do a table start of -1. Leave the delta table the same. And go back to your graph. Just hit graph. Oh, snap. Hit second graph, dummy. All right. Now arrow down because that's going to get us closer and closer to 0. And what's happening to your y values?
It's increasing into the negative.
Oh, right. They're getting bigger, but in the negative direction. So they're going, yeah, they're approaching what? They're approaching -100. You don't have to do this, but I'm going to. You see that -0.01 that I've got highlighted? I'm going to go back to my table set, and I'm going to start at -0.01. And I'm going to make these increments even smaller. I'm going to go by 1,000th. Now look what those y values are doing. Look at those. How low will they go? How low is very low? What do we call it? Negative infinity. That's what we call it. We call it negative infinity. So here's what we know from looking at that picture. We know that as x is getting closer and closer to 0 from this side, the y values are doing what? They're going up this way, aren't they? And as the x values are getting closer, y'all pay attention. To 0 from the left, they're going this way, right? Guys, when something like that happens, this line that those points are getting closer and closer to but never touch, you know what it's called? It's called this word right here. It's called an asymptote. It's called an asymptote. In this case, we've done asymptotes a little bit. That's called a vertical asymptote. Vertical asymptote. Now, let's talk about some other stuff that you see in this picture. We're not going to examine every graph like this. I just want you to look at this one, okay? Now, go back to table set, which is second window. Go back to table set. And you're going to make some changes here. I want you to table start at 1, but I want you to count by 5s. So we're going to go 1, and then 5 more, and then 5 more, and then 5 more, okay? Go to your table. Ah, snap. I don't want fractions. Let me see here. Let me go to mode. I want decimals. Let's see if that'll give me decimals. Well, snap, that didn't give me decimals either. Why did that not give me decimals? Is anybody getting decimals? A few of you? Well, I'm getting decimals. Okay, here's what I want you to look at, especially, well, everybody look at it, but it'll be easier, I think, for you to understand if you have decimals. Just start going down. Now we got decimals. Just keep going down. What's happening to those y values as x gets bigger and bigger and bigger? How small do they get? Okay, now infinitely small means negative 100 and negative 1,000 and negative 1,000,000. Is that what these numbers are doing? Closer to zero. That's right, they're getting closer to zero. Now, I don't care how big you get, you're never going to get zero. Now, somebody's going to say, yeah, it does eventually equal zero. Well, it really doesn't. If I go here and I make this 1,000, and I go in it, and I can't buy 100. You see these nasty numbers? This means scientific notation, and that is just super, super close to zero, but it's not negative. See those numbers? Woohoo! Now, eventually, it's going to say zero on the screen only because of rounding issues. Only because of rounding issues. So let's think about this. As x is getting great big, what are the y values doing? Getting closer and closer to what? To zero. What do you think's happening on the other side? As x is decreasing, going to negative infinity. Yeah, that's right. They're getting bigger, but closer and closer to zero. Do you know what that's called? You remember the word? It's called a horizontal asymptote. Phones put away, gentlemen. That's called a horizontal asymptote. This thing, as x approaches infinity, this thing's going closer and closer to zero, like that. So what we're going to talk about is horizontal asymptotes and vertical asymptotes, and where your curve crosses the x-axis. Does this particular curve cross the x-axis anywhere? No, it does not. Why? How do you determine where a curve crosses the x-axis? I want you to think about something. Guys, you look tired and you look bored out of your mind, and if you're bored out of your mind, I'm real sorry, but this is something you need to learn, okay? I know. Every point we've got here, what's the y value? 0. 0. So here's my question to you. When is a fraction ever equal to 0? I'm sorry? When the numerator is 0. If I have 0 divided by 5, 0 divided by negative 3, those are all 0. So a fraction is equal to 0 when its numerator equals 0. Well, I want you to look at this. Not that way. When is that numerator ever equal to 0? It's not. So there aren't any x-intercepts or zeros. There aren't any. So here's what we're going to do. When you do these problems, you're going to write vertical asymptote, horizontal asymptote, zeros. Those are the three things that you're going to have to decide. Can you tell me what this vertical asymptote is? Okay, is it x equals 0 or is it y equals 0? Let's talk about it. What are the coordinates of that point right there? 0, 1. What are the coordinates of that point right there? I think that's 4. That's all right. 0, 4. Here? 0, well, it's 7. But what's common about all those? The x value is 0, so that line is x equals 0. Now, we also said there was a horizontal asymptote. And we said the horizontal asymptote's right there. What's the equation for that horizontal asymptote? Y equals 0. Now, Where does this curve cross the x-axis? Never. So there aren't any zeros, so you're just going to put none. Now, this is where I'm going to let you use your calculator, and I hope you are very grateful, because this is a pain in the neck when you have to do it all by hand. I want you to see how many if we just look at that vertical asymptote, don't worry about the horizontal, just worry about the vertical. How many pieces was the graph divided into? No, don't worry about the horizontal asymptote, just the vertical one. A piece on the left of the vertical asymptote and a piece on the right. Okay? So, what I want you to do, you're going to actually plot 3 points on each side of that vertical asymptote. And you say, well, what? What do I have to do? What does that mean? You're going to go down here and you're going to make a chart. But I'm not going to ask you to do all that by hand. On this one, it's real easy because it's just 1 over x. I'm going to show you how to do that on the calculator. I want you to pick, first, let's pick 3 numbers that are bigger than 0. We can pick 2, 1. Now, I'm going to show you the other number I want you to pick. I want you to pick half. And then we're going to pick 3 numbers on the other side of the vertical asymptote. 4, negative 4, fine. What else? Okay. So we could pick negative 4. We could pick negative 0.5. Negative 1, fine. Now what we're going to do is we're going to go back to the calculator and we're going to see what are the y values. Now there are 2 ways you can do this. One way, after you turn your calculator back on, go to table set, and let's start this at 0, and let's count by 1. Now go to table. Have you got this screen up? Okay, so when x is 2, what is y? Look on here. Look on your screen. When x is 2, what is y? A half. When x is 1, what is y? 1. Now we can't see 0.5, can we? I'll show you how to do that in a minute. Arrow up. Use your up arrow until you find negative 1. When x is negative 1, what's y? Negative 1. When x is negative 4, what's y? Now again, these 2 numbers, the negative 0.5 and 0.5, we can't see. Let me show you how you can find those. You can find those by doing this. Go back to your table set. Are you there? Change your delta table to 0.5. Change your delta table to 0.5. And then go back to your table. Now in my screen, I'm going to have to start arrowing down. Look, there's negative 0.5. And there's positive 0.5. So what have we got? Negative 2 and 2. When the problems get more complicated, I promise you it's a whole lot easier to do this on your calculator than it is to do it by hand. Now what you're going to do is you're just going to plot those points and you're done. Negative 4, negative 1/4. Negative 1/2, 2. That's not right. Negative 2, dummy. Are you plotting them? Negative, it'll help if I can do this right. Negative 1/2, negative 2, negative 1, negative 1. Then the other side is 2 and 1/2, 1. I'm just having trouble this morning. 2 and 1/2, 1 and 1, and 1/2 and 2. And draw your picture. You know what the picture looks like. You got it on your confound screen. And that, ladies and gentlemen, is what we're going to do. I'm sorry? The aha moment? Okay. Now, I want you to look at these. Do you remember Move the Monster? Now, it sounds familiar. Do you remember all this is going to be is left and right and up and down? Look right here. When you've got a +3 in with the x, do you remember what that does to the graph? Left 3. So this picture here for A is going to look exactly like this picture, except everything is what? Shifted to the left 3 units. What's going to happen to B? Down 3, good. So again, this one is the picture we've got above, 1/x, but everything's just shifted down 3 units. What about this one? Right 2 and up 1. Good. Good. Now remember, guys, every one of these had a parent of 1/x. So all that's doing is taking this picture here and moving it. Now when you move, those vertical and horizontal asymptotes may move too, okay? Look at the bottom here. Can you fill in the blank? Vertical asymptotes occur where? Where? Where did the vertical asymptote occur in this one? And where was x? Where's x? In the denominator. You have a vertical asymptote where the denominator is 0. Where the denominator is 0. Remember, spring break starts a week from tomorrow, okay? We're going to make it. We're going to make it. All right. Unlike the graphs we've done before, we see today, the graphs we see today will have polynomial functions in the numerator and denominator. This will change how we identify horizontal asymptotes. You're going to learn some rules today that right now you're just going to have to memorize. But if you ever come to the point that you take pre-calculus or AP calculus, you understand why all this works. Okay. Vertical asymptotes. Now, I know you're like, duh, we just said this. Vertical asymptotes occur where the vertical asymptotes denominator is 0. Side note, now we've talked about this already. What happens when the numerator is 0? Not undefined. Not undefined. That's your x-intercepts. That's where your curve crosses the x-axis. That's what we call x-intercepts or zeros, okay? And you're going to have to find those. I don't know if she's got something written in here or not. Okay. When the numerator is 0, the graph crosses the x-axis. That's called an x-intercept, or it's called a 0. That's my weird z. Three things you have to be able to find for me: a vertical asymptote, a horizontal asymptote, and a 0. Those are the three things that I expect you to be able to find. Now this is just going to weird you out just a little bit. Horizontal asymptotes are just a little bit weird. Stop it. Sakes. Listen, I'll get you some breaks built in today because I know you guys are struggling. I'll get you some breaks. You struggle every day. Well, do you remember how to find degree of a polynomial? Remember how do you find degree?
Definitely should know.
Very close.
Oh, I don't think so. I think as long as I'm happy, I think we're going to stay where we are because I'm here all day. Look at this expression. That's polynomial. What's the biggest exponent? 3. So this is a degree 3 polynomial. And we call that a cubic, remember? I give you this. What's the biggest exponent you see? Exponent is the degree is the exponent. Yeah, it's a 1. Do you remember what that's called? A degree. If a degree 3 is cubic, a degree 1 is. Yeah, it's a monomial. No, it's not a monomial. A monomial means one term. Linear. Linear. That's linear. Do what? Mono means one, but it means one term, not an exponent of 1. What's the biggest exponent? 2. So what's this called? Quadratic. Good. Good. That's a constant. What's its degree? Yes. 0. 0. Is there an x with it? No. So the degree is 0. That's a constant. Okay. When the degree of the numerator is less than the degree of the denominator. What's the degree of the numerator? What's the degree of that? 0. What's the degree of that? 1. When the degree of the numerator is less than the degree of the denominator, then the x-axis is your horizontal asymptote. And that's the line y equals 0. Write that down. Look right here. What's the degree? 1. What's the degree? 2. When the degree of the top is smaller than the degree of the bottom, y equals 0 is your horizontal asymptote. You're just going to have to memorize it right now. When the degree of the numerator and the degree of the denominator are the same. What's the degree up here? 1. Degree down here? 1. What's the degree here? 2 and 2. When the degrees of the numerator and denominator are the same, then your horizontal asymptote is it's the coefficients of the leading terms. So 2 divided by 1. That's right. 2 divided by 1. Here, what's the coefficient of your leading term? What's the coefficient of your leading term? So 1 divided by 1 is 1. So the leading coefficient of the numerator divided by the leading coefficient of the denominator. Oh, remember today's an RTI day. Everybody know where you're going? We'll check it. We'll check toward the end of class. But remember, class will end at 10 till instead of 5 till. Okay. When the degree of the numerator is bigger than the degree of the denominator. What's the degree here? 2 here, 1. What's the degree here? 3 here, 1. When the degree of the top is bigger than the degree of the bottom, you don't have a horizontal asymptote. There's not one. Now, we're going to do A, and then I'm going to give you a break. Okay? Identify horizontal and vertical asymptotes. Let's talk horizontal first, since you just did one. Horizontal asymptotes, what do you compare? You compare the degrees. What's the degree of the numerator? 2. What's the degree of the denominator? 2. So, that's right. 2 divided by 1 is 2. So the horizontal asymptote, remember, is y equals 2. Make sure that they're in standard form. If they're not in standard form, this doesn't work. So put them in standard form. Now your vertical asymptotes, look back at your notes. Vertical asymptotes happen when the denominator is 0. I want to know on this one, when is that denominator equal to 0? How do you solve that? You factor. You factor. Levi says minus 3 plus 2. Is he right? What's this give you? Minus 3x plus 2x. Does that add up to give you minus 1x? You betcha. All right, so let's finish it. If x plus 2 is equal to 0, then x equals negative 2 and 3. This one has 2 vertical asymptotes. 2 of them. So you're going to write it like this. Vertical asymptote at x equals negative 2 and 3. Now the last thing is zeros. And remember, zeros and x-intercepts mean the same thing. When do you have a 0 or an x-intercept? Look back in your notes, right above the box on the previous page. When do you have an x-intercept or a 0? When the what? No. Numerator. Numerator. When the numerator is 0. Denominator is 0 gives you a vertical asymptote. Numerator is 0 gives you a 0 or an x-intercept. So I want you to look at the numerator. What's the first thing you see? What's the GCF? Times what? Self? Am I finished? Will that factor? 2 times 2 is 2? Is this a difference of 2 squares? Because that's what some of you are trying to do. Is it a difference? Does 2 have a nice square root? You're finished. That's as much as you can do. Okay, so we factored it, so now we set each factor equal to 0. Can 2 equal 0? Now throw it out. When does x squared plus 2 equal 0? That's right. Subtract 2 from both sides. Square root. What's the square root of negative 2? That's imaginary, isn't it? You cannot graph an imaginary number. When you get something like this, when you have to take the square root of a negative number, that means there aren't any zeros. This curve never crosses the x-axis. So you're going to say none. Now, before I give you a break, I just want to show you something. If I were having you to graph that problem, and I'm not, but if I was having you do it, the first thing I would have you to do is find these three things and graph them. And that's why you have rulers and colored pencils. So what we'd be doing, and obviously you'll have graph paper and you've got graphs on your notes, but we would be going like this. I have a horizontal asymptote at y equal 2, so I'd be drawing that in. And I have vertical asymptotes at x equal -2 and at x equal 3. And don't ever cross the x-axis. So you are going to get that before you ever look at a picture on your calculator. Okay? Short break. If you need to go get a drink of water, go get a drink of water. Now, let's take a look at B. Now we're going to do three things. Zeros, vertical asymptotes, and horizontal asymptotes. On B, I don't really want to use yellow. Zeros. Where do zeros happen? When the numerator is 0. I want you to look up here. Where is this numerator equal to 0? When what's -2? When x is equal to -2. Let's do horizontal asymptote. Horizontal asymptote, you compare the degrees. You compare the degrees. What's the degree of the numerator? 1. Degree of the denominator? 2. Look back at that table. When the degree of the top is smaller than the degree of the bottom, y equals 0. That's your horizontal asymptote. Vertical asymptotes happen when the denominator equals 0. Good. So your question here is, when is that equal to 0? Let's factor it. Okay. Factor it. What do we got? Is that it? What's x equal? -9 and 1. And those are the two numbers where that denominator is 0. So those are your vertical asymptotes. Vertical asymptotes are x equals. You got two of them, -9 and 1. You try this last one. Try zeros first. When does a fraction have zeros? When the numerator equals 0. Good. When is that numerator equal to 0 on C? Plus or minus 1, right? Plus or minus 1, because remember, if you said x squared minus 1 equal to 0, how could you solve that? Bless you. You could add 1 to both sides and square root, so you'd have x equal plus or minus 1. Or you could say, oh, x squared minus 1 is a difference of two squares. Right. So we've got two zeros. Horizontal asymptote. Let's do that one next. How come? Look at your table. If the degree of the top is bigger than the degree of the bottom, there's not a horizontal asymptote. Good. Vertical asymptote. A vertical asymptote happens when the denominator is 0. When is this equal to 0? When what is 0? Aha. When x is 0. Questions about how to find those three things? Okay. Now let's look. To graph a rational function, find the vertical and horizontal asymptotes, and you're going to put and zeros. Make a table and graph at least 3 points in each part of the graph, meaning on each side of the vertical asymptote. And find the domain and range. Okay, how many practice ones are there of these? 5. We ain't going to get through 5. We'll get through some. All right. Let's go. Zeros, vertical asymptote, horizontal asymptote. How do you find zeros? When the numerator equals 0. Good. Add 2 to both sides. Divide by 4. X equals half. Guys, what does that mean? What does it mean to have a 0? Crosses the x-axis. So you can go over here and cross the x-axis right there. That x equals a half. Horizontal asymptote. Horizontal asymptote. What do? Compare the degrees. What's the degree of the top? 1. Degree of the bottom? 1. So you take those coefficients. What's 4 divided by 2? So y equal 2 is your horizontal asymptote. You take your ruler and your colored pencil. And on y equal 2, you draw a horizontal line. Are you okay? Vertical asymptote. Vertical asymptotes happen when the denominator is 0. Good. When is that denominator equals 0? What do? Yeah, how do you solve it? Subtract 2. Divide by 2. X equals -1 is your vertical asymptote. So you're going to take your little ruler and your little colored pencil, and you're going to draw a vertical line through x equal -1. Now, do you notice that we've already got 1 point graphed right there? Now, the rule said you need to find 3 points on each side of the vertical asymptote, okay? We've already got 1 on the right side of the vertical asymptote, so we just need to find how many more? 2. And then we need to find 3 on the left side of the vertical asymptote, okay? So this is where you're going to make a table. You can do x, y. Now, on the right side, so over here, we've already got 1. Let's pick 2 more x values over here. 3, fine. Give me another one. 7, all right. You can do more if you want, but we've got enough now, don't we? We had 1, we got 2 more. Now let's go on the other side of the vertical asymptote. -4, fine. What else? -2, fine. One more. -5, fine. Now you say, well, okay, so how do I find the y values? Well, I used to make students take those numbers that I wrote in green and plug them in there and find out what the y values were. But now I'm just going to let you use your calculator, okay? So what you're going to do is you're going to go to your y equals screen. You're going to type this in, but make sure you use your fraction command. Where's my calculator? Use your fraction command. Go to your table set. Whoops. Go to your table set. Now, I would always encourage you to start at 0 and count by 1. And then go to table. And then just go up and down there looking for your x values and write down your y values. Okay? To find the negatives, just arrow up. Now plot those points. -4, 3. -2, 5. -5, 2.75. 3, 1.25. 7, 1.65. Are you getting points in these places? Now connect them. It's going to look like this. Now listen, for our purposes right now, you're not going to cross a vertical or a horizontal asymptote. If you do, you got a mistake. You can go to your calculator, graph, and make sure that your picture is correct. I'd like to see if we can work through one more of these, okay? Do you have the general idea of what we're doing? That's the end of that page, right? We'll deal with domain and range tomorrow. Thank you for reminding me. We'll deal with that tomorrow. Let me see here. We got to do number 2. Number 2 is probably the one that's got the most junk on it of the rest of the questions. Zeros, horizontal asymptote. I'm going to try to put them in the same order every time. How do you find zeros? How do you find zeros? No, degrees find what? Degrees find horizontal asymptotes. So if you want to, look, go back in your notebook. Where are zeros? How do you find zeros? Where the numerator is 0. We're going to take that numerator and we're going to set it equal to 0. Okay? How do you factor that? No, I don't want to add 12x. GCF, good. What's the GCF? Good. Times what? So 3x equals 0 or x minus 4 equals 0. Okay, I'll plus 4 on this one, so x equals 4. Good. And x equals 0 because 3 times 0 is 0. So my curve's going to cross the x-axis twice at x equals 0 and at x equals 4. Let's go down to horizontal asymptote. You compare the degrees of the top and bottom. What's the degree of the top? 2. What's the degree of the bottom? 2. So we're going to divide 3 divided by 1 is 3. So my horizontal asymptote is y equals 3. My vertical asymptote, where do I find those? Denominator is 0. X squared minus 2x minus 3 equals 0. Good. So x would equal 3 and negative 1. I got 2 vertical asymptotes. Write them both down, 3 and negative 1. Now, we're not going to finish, but I want you to at least draw these things in. Plot your zeros. I got a 0 at x equals 0, and I got a 0 at x equals 4. I have a vertical asymptote at x equals 3. And I have a vertical asymptote at x equals negative 1. I have a horizontal asymptote at y equals 3. That's a lot of stuff. Could you stop? Now, I want you to look at this. How many vertical asymptotes do I have? 2. Now, how many sections do those 2 vertical asymptotes divide the graph into? 3. So you're going to have 3 tables. One for this section, one for in between, and one for this section. Okay? Now, because of time, that's all we can do right now. But I'm going to give you this, and there are 3 of them I'm going to have you do. Okay? I'm not going to have you do one that's got 2 vertical asymptotes. Just a minute. So I'm only going to give you 3 of these to do. All right? Now, you can pull up, you can pull up Desmos, which is a graphing calculator. Everybody has that on you just do desmos.com and you can pull that up. Now, when I give this to you, I'm going to give you a piece of graph paper as well. Number 1, number 2, and number 6. Those are the only 3 you're going to